Okay, hello everyone. So we are back for the last part of the paper. So now we have a graph of both the atomic radius as well as the ionic radius. Right, and we see that the atomic radius, I'm going to highlight this in blue, is this solid line here, while the ionic radius highlighted in red goes down like that, and then suddenly below the blue line, and suddenly it goes up, and then neon has like nothing. Okay, so this is ionic radius, that means it's the size of the ion. So suggest why there's no data for the ionic radius of neon. So we have all learned, right, that when an element forms an ion, it will get a full valence shell of electrons. So it loses or gains an electron to get the full valence shell of electrons. But what about neon? Right? What about neon? So we should know that neon has a electronic configuration of 2.8, and that's already full. So that means when there's already a full valence shell of electrons, neon cannot lose or gain electrons. So suggest why there's no data for the ionic radius of neon is because neon has a full valence shell of electrons, and do not form ions. So I need two parts to this answer. So firstly, I need to say that it has a full valence shell of electrons, and then I need to say that it do not form ions. Now the next question. Explain why some ionic radiuses are smaller. So I guess it's this part over here. But why some are bigger? Okay, so let's think about it. Alright. So lithium is 2.1. And 2.1 means that if I'm forming an ion, lithium ion, here Li plus, would be 2, 2. So you can see that lithium has 2 shells, lithium ion has 1 shell. Beryllium is 2.2, the beryllium 2 plus would be just 2 again. Right? So you can see beryllium atom has 2 shells, beryllium ion has 1 shell. Boron is 2.3, beryllium boron ion B3 plus would have just 2. So again, 2 shells, 1 shell. Carbon also same, 2.4, so this is 2 shells, 1 shell. Alright, then what about nitrogen? Nitrogen atom is 2.5, and because we have 5, right, so I will not lose the 5 electrons, I will gain 3. So actually the nitrogen ion, nitrite ion, N3 plus is 2.8. So we can sort of see that it remains the same number of shells, but there is an increase. Right? Same, this one is 2.6, this one oxide ion O2 minus is 2.8, there's an increase. And then fluorine atom 2.7 and fluoride ion F minus is 2.8. Again, there's an increase. So firstly, I should be able to very easily explain why lithium ion, beryllium ion, boron ion, and carbon ion, right, is smaller than the atomic radius, because that's what I'm trying to explain. Right? Why some ionic radius are smaller than the atomic radius, while other elements' ionic radius is larger than the atomic radius. So I can explain why some are smaller. So since, right, I want to explain why, first I want to explain why lithium, beryllium, boron, and carbon is smaller. So since lithium, beryllium, boron, and carbon loses 1 electron shell when it forms an ion, right? The ionic radius is smaller than the atomic radius. Right? So since lithium, beryllium, boron, and carbon loses 1 electron shell when it forms an ion, the ionic radius is smaller than the atomic radius. Okay, so that's for the first 4. Now for the next 3, why is it bigger? So you can see that the nitrite ion, oxide ion, and fluoride ion do not lose the electron shell. So we just write, so since nitrogen, oxygen, and fluorine, right, does not lose an electron shell when it forms an ion, the ionic radius is not smaller than the atomic radius. Okay, so I hope that has helped you understand this a bit better. It might take some time to understand it, so please feel free to rewatch the video if you need a bit more time. Is that okay? Alright, so all the best. Bye-bye.